In this video, I'm going to explain how to draw ray diagrams through a prism. By the end of the video, you will be able to solve such kind of problems. So first, let's get into some of the basics. So how does light bends when it moves from one medium to another? So we have three situations in this case. So the first case is denser to rarer. An example of that will be from glass to air. The second case will be rarer to denser. Example of that will be air to glass. And the third case is when the light is incident normally. In the first case, when the light travels from denser to rarer, then in that case the light will bend away from the normal. In the second case, when the light travels from rarer to denser, the light will bend towards the normal. And in the third case, if it is incident normally, then the light will pass undeviated. Now let's discuss the next topic, angle of incidence and angle of refraction. The ray hitting the surface is called as the incident ray. The ray after refraction is called as a refracted ray. To identify the angle of incidence, first we have to draw the normal. So the angle between the incident ray and the normal is called as the angle of incidence. We use I to represent it. The angle between the refracted ray and the normal is called as the angle of refraction, and we represent it with a letter R. So let's calculate the angle of incidence and angle of refraction in the following question. So keep in mind, the angle of incidence is the angle between the incident ray and the normal. So 30 is not the angle of incidence. So in order to calculate the angle of incidence, we know the angle between the normal and the surface is 90 degree. So angle of incidence will be equal to 90 minus 30, which is equal to 60 degree. Similarly, we know angle of refraction is the angle between the refracted ray and normal. So in this case, taking the angle between the normal and the surface as 90 degree. So angle of refraction will be equal to 90 minus 70, which is equal to 20 degree. Next, let's discuss critical angle, refraction and total internal reflection when the light passes from denser to rarer medium. So in almost all the questions, the critical angle of glass is taken as 42 degree, and also in these cases, we are taking the light is moving from denser to rarer. So let's take the first situation when the angle of incidence is less than the critical angle. Say the angle of incidence is 30 degree. So in this case, 30 degree is less than 42 degree. So the light will undergo refraction. In the second case, let's take the angle of incidence is equal to the critical angle. So you can see over here, angle of incidence is 42 degree. Angle of refraction will be 90 degree. So when the angle of incidence is equal to the critical angle of refraction will be 90 degree. Let's take the third situation. In this case, angle of incidence will be more than the critical angle. So let's say the angle of incidence is 65 degree. Then in this case, the light will undergo total internal reflection. Also keep in mind, when it undergoes total internal refraction, the angle of reflection will be equal to the angle of incidence. That is, it will be 65 degree. Now pause the video and try to complete the following ray diagrams. Once you're done, you can resume the video. So in the first case, the angle of incidence is 60 degree, which is more than the critical angle. So it will undergo total internal reflection. And angle of reflection will be equal to 60 degree. In the second case, angle of incidence is 35 degree, which is less than the critical angle. So it will undergo refraction. In the third case, the angle of incidence is 42 degree. So in this case, the angle of refraction will be 90 degree. So let's try to solve this problem. When you solve problems based on prism, take one surface at a time. So in this case, let's discuss the first surface, that is AC. So here the light is incident normally. So as I have already discussed, if the light is incident normally, it will pass undeviated. Now let's look at the next surface. So in this case, first we have to find the angle of incidence. To identify the angle of incidence, we draw the normal and then you get the angle of incidence. So in order to find I, first we need to find X. We also know this angle will be 90 degree. As you can see, it is a triangle. As you have learned in geometry, the sum of angles in a triangle is 180 degree. So what we can do, we can write X plus 60 plus 90 is equal to 180. X is equal to 180 minus 150. X is equal to 30 degree. We can find I. So now we know the angle between the normal and the surface is 90 degree. So we can find I is equal to 90 minus 30, which is equal to 60 degree. So the second step is to observe what is the relationship between the angle of incidence and critical angle. So just to revise the concept, if the angle of incidence is less than the critical angle, then it will undergo refraction. If it is equal to critical angle, then the angle of refraction will be 90 degree. And if the angle of incidence is more than the critical angle, then it will undergo total internal reflection. Also keep in mind the light should go from denser to rarer. So if you look at our question, what is the angle of incidence? So the angle of incidence is 60 degree, and we also know critical angle is 42 degree. So in this case, since the angle of incidence is more than the critical angle, it will undergo total internal reflection. And also angle of reflection will be 60 degree. Now let's look at the next surface where the light is hitting. So again we have to find angle of incidence. So to do that, we'll draw the normal. We'll mark the angle I. So in order to find I, we need to find Y and we need to find Z. So you can look over here, there is a triangle. So to find Z, we can subtract 90 minus 60, which is equal to 30. And to find Y, we can use sum of angles in a triangle property. So Y plus 90 plus 30 is equal to 180. Y is equal to 180 minus 120. Y is equal to 60. So next we have to find I. So I will be equal to 90 minus 60, which is equal to 30 degree. If you look at I is less than the critical angle, so it will undergo refraction, and since the light is traveling from denser to rarer medium, it will bend away from the normal. So this is the final solution for the problem. Copy the diagram and try to solve this problem on your own. Once you are done, you can resume the video. Now let's look at the solution. So keep in mind, this 42 is not the angle of incidence. So in order to calculate the angle of incidence, we have to draw the normal. And we have to find the angle of incidence. So angle of incidence will be equal to 90 minus 42, which is equal to 48. Next, you have to see if the angle of incidence relationship with critical angle. Since angle of incidence is more than the critical angle, it will undergo total internal reflection. Also, angle of reflection will be 48 degree. Now, in this surface, we have to find the angle of incidence. So let's mark the normal and let's find the angle of incidence. So to find the angle of incidence, we have to find two angles, one angle over here and the other angle over here. Let's call this angle as A and the angle B. So angle A will be equal to 90 minus 48, which will be equal to 42. And angle B, we can calculate by using sum of angles in a triangle. So 180 minus 90 plus 42. So which is equal to 180 minus 132 equal to 48. Now we can find the angle of incidence in the second surface, which will be equal to 90 minus 48 equal to 42. And over here, the angle of incidence is equal to critical angle. So angle of refraction will be 90 degree. So this is the solution to this question. I will upload a worksheet in the description, which you can use for practicing more problems based on Prism. If you found this video useful, do like and subscribe the channel.